The topic is editor, we call it as IDE, compiler, interpreter, linker, loader. We'll see the details about each of this. So before we move to them, let's see what are the steps to while executing a program a programmer should follow. So as I said, job of the programmer is we write the program and also run the program, and usually this involves 4 steps. The first step is writing and editing the programs. So you have to type the program, and second step is compiling the program. And then third is linking the program with the required library modules. I'll explain all these steps in detail now in a minute. So next is executing the program. So these are the steps. So after executing it, we usually go for debugging, etc. Let's see the first topic called IDE, that is Integrated Development Environment, right? So this is basically a software application that helps the programmers or developers writing and compiling, running, and also debugging the programs in one place. What it means, instead of writing in one software and compiling in the other software, running in the other software, debugging in another software, this IDE includes at one place. Integrated word is there, right? So this integrated word indicates all these programs are built in a single software application, okay, at one place. So that becomes easy for a developer or a software engineer to write and compile and run the program at one place, right? So this it basically improves the productivity as it combines the tools like code editor, compiler, interpreter, or else debugger, and building and testing tools all together are placed at one place. Now, you know that usually writers use the text editors like Microsoft Word or some other editors. So accountants use the spreadsheets like MS Excel sheets and all. So similarly, IDE used by the programmers. So what are the examples of the IDEs? So you can see Visual Studio Code, VS Code is a one IDE. Means what? This IDE software, VS Code software contains programs which enables us to write the program, compile the program, and execute the program as well as debug the program. So similarly, we have other tool called PyCharm. This is basically used for running the Python programming. And similarly, IntelliJ IDEA and Eclipse and so on. So there you can have any other examples also to write and edit the code and compile the code. So now this is an example. You can see the screenshot, some Visual Studio. So here is the place where you can write the program. And here right hand side you can see, top of this you can see build, debug, test, analyze, so on, so options, right? And you can have an option for editing. So all these tools, all these programs, all these tools you can say are built at one place. This is the IDE, we call it as Integrated Development Environment, which is used by the programmers. And you can see different variables, what are the data type. It is for it makes you debugging easy. I'll tell you what is meaning of debugging. So basically debugging, here it is, you verify whether each statement is executed or not, and also what are the current variables and the data present in the variables. Okay, we'll see once we are actually executing the programs. I'll tell you what is the meaning of variable, what is the meaning of debugging, and what is the current instruction being executed, right? For now, IDE is a software tool. It will have these kind of tools here, right hand side. So it depends. So you can see how much memory is being utilized. All that stuff is possible in one tool. So now let's see the steps. As I said, editing IDE we have seen. Now the next steps are compilation, execution, and so on, right? So any programming language, this needs to be translated first. Okay, why this translation is needed? So basically, you know this, CPU understands only machine language. Having said machine language, it is a binary code. Binary code means what? It includes only zeros and ones. So CPU understand only zeros and ones. So when I say high level languages, what it means? The languages which are human readable, means we can easily understand and read it. It looks like a plain English, and this plain English must be translated to zeros and ones, because CPU understands zeros and ones only. So what are the examples for this high level language? Like C program is a high level language, Python is a high level language, so on. So many are there. And these languages, when I say language, means set of instructions. These instructions are in a human readable form, high level language, human readable form. And these instructions must be finally converted or translated into zeros and ones. Okay. And this task is basically done by either a compiler or interpreter. So I'll tell you the difference between what is a compiler and what is the interpreter in a minute. So compiler translates the entire code, whatever the code you write down here, this is your code, and this code, high level code, is translated into machine code at once. So what is the high level language? C, C++, Java, these are the high level languages, and the code written in this is at a time is translated into machine code using the compiler. Okay, translated having said, these high level instructions are translated into zeros and ones. So that is the job of the compiler, right? What are the compiled languages? Means compiled languages are this C, C++, Java are the compiled languages. Okay, and what about the interpreter? Interpreter is basically translates. When I say translate, what it means? This high level instructions, means high level language, that is human readable code, is converted into zeros and ones. That is the meaning of translation. So after converting, it also runs the code line by line. So line by line means, let us say I have written line 1. So this is L1, this is L2, and this is L3. Let us assume. So this code is first translated into zeros and ones, then we'll run it. So what is the meaning of running? It is actually bringing to the main memory, and in that main memory you will give the input to the program, and also you will expect the output from the, you will expect in the sense what? CPU execute by taking that input and gives you the output. That is the meaning of running. I'll explain in detail when we are actually dealing with the program. Right. So line by line. So first line is compiled, that is translated, not compiled. First line is translated. When I say translated, high level instruction is converted into zeros and ones. Then also immediately we are running that particular only one instruction, right? And it will go to the next instruction. This is also translated into zeros and ones, and then we'll run this also. Then the process repeats. So these kind of languages are called interpreted languages. Interpreted languages means what? One instruction after other instruction is been translated and run one after line by line. Okay. So these interpreted language examples are Python language and MATLAB language are the interpreted languages. So now let's see in detail what is the meaning of compiler. I have already explained you. Compiler is a program. So all in the computer science, all are the programs. Remember this. So compiler also program, and this compiler program translates. So when I say translates, so this high level language is converted into machine level program. Okay, and this machine level program then executed at any time later on. So we are not executing immediately using the compiler. We are executing later on. But compiler task is what? It is only translating the high level language to the machine level language. Let's see here how it can be. So you can see here, this is the high level language, some high level language. Let us assume C, or doesn't matter what language it is. C, it is not, you can think of any other language. It looks like a human, point is it looking like a human readable language. That's important, right? So hello, some word, and this is basically print also human readable and so on. So some instructions are there. So what this compiler will do, this high level language is converted into, as I said, so we'll give this high level language as an input to the compiler program. This is also a program, and this program translates. So translates means what? It will convert basically. So this converts it into zeros and ones. So you can see here, this hello and print, everything is converted here into zeros and ones. Now this zeros and ones can be later on, not immediately, later on run on any machine specific. Okay. As high level language, as I said, they can run on any machine because they are portable. Whereas assembly language or low level language, they are not portable. Once they are compiled, once they are given it should be executed only one particular hardware. If you want to run it in the different hardware, you need to try different instructions. But in the case of high level languages, this once they are converted into machine level, they can run on any code at any time. Now later on I am saying this machine level language, okay, this is being executed on a CPU later on. Executed, when I say, actually we are running this program. When I say running this program, what it means, we will give this input to the program at command prompt using the console. We'll give the input to this, and also we'll get the output out of this. So after executing this, executing means what? It will load the data and instructions to the CPU, right? And after loading the data and instruction, whatever the data you pass or whatever the data present in the instructions, and also instruction itself will load it into CPU, and it will perform the operation. What are the operations? I already told: logical operations, arithmetic operations. Arithmetic operations are addition, subtraction, multiplication, division. Logical operations are and, or, not, so on, so on. Okay, these operations are performed on this particular binary data, and then it will give you back the output. Okay, and that output is executed. This we call it as a running or executing the program. Running or executing the program. Okay. Now this is how compiler works. Let's see next component, next software, interpreter. So as I said, compiler is used by the compiled languages, such as it is not used by all the languages. Only some languages we call them as a compiled languages. So such as C language, Java, and so on. So when as an interpreter, so interpreter, what it is in? It is also a software. It is also software application or a program. It will do two things. It translates and execute at a time. It translate, execute each instructions immediately. Okay. So high level instruction is taken, and that is been converted into zeros and ones, and immediately it will run. These are the two steps: translation and running. So translation step is performed, and also running also performed immediately, one instruction after other instruction. So it will take first instruction, it will translate, okay, zeros and ones, and it will run. These two steps are performed here. Whereas compiler, what it is doing, it is only translating the entire code. Difference you see, entire code at a time it is translating to zeros and ones. That is machine code. But what is interpreter is doing, it is taking one instruction only, it is translating. This is instruction 1, it is translating to zeros and ones, then it is running. This is the difference between compiler and interpreter. Okay, you can see here. So let us say this is your high level program, and this high level program is given to the interpreter. Interpreter is also program, and this program basically, this is a user written program. We are writing the program, and this is already predefined program. Some software application has been already written there, and you will give your program to this interpreter, and this interpreter convert into machine level language. After converting this, we call it as a translation. After translation to machine level language, it is running on the actually CPU immediately. So instruction 1, let us say this is the first hello print is the instruction. Let us say this print instruction is converted into zeros and ones, and this print instruction is run in the CPU immediately. And now that will go to the second instruction. So that second instruction also interpreted, and that means it is been translated. Then after that it is been run on the code. So similarly other instructions. So this is how interpreter works here. Right. So they already told you it translates each high-level instruction to its equivalent to machine instructions and immediately executes them. This is the difference, very important, you should understand. And this process is repeated for every instruction. All the instructions, whatever you have written in the code, these instructions, this process is repeated. Means what? It takes one instruction, translate into zeros and ones, that is assembly language, machine language, then translate into execute on the CPU. The next step comes is assembler. So assembler is a special to assembly language. So this assembler is used to translate assembly language. Basically, it is a low-level language. It is not used to translate the high-level language. Assembler is used to translate the low-level language to a machine language. What it means? So let us see example here. So assembly language, I already mentioned earlier, it looks like this. This is also low-level language which uses the mnemonics like move, add and all. It is also little human readable when compared to zeros and ones. Okay, so this is the machine level language. It is a one level above, you can think. And this again given to the input given as an input to the assembler. Assembler translates into zeros and ones like this. Okay, so difference is here is it takes only low level language, that is assembly language as an input, instead of taking high level language such as C and Java, etc. Right. Now let's see the linker. So linker is basically a special program. As I said, all of the programs in in the software environments. So these programs combines object files. So basically objects files are specific to like language like Java. Java generates an intermediate file. It takes the high level language, that is a Java program, and that is being first converted into object files, right? And they are basically generated by the compiler or assembler. Okay, and these intermediate files and other pieces of code also, apart from this intermediate object files, it also combines the other pieces of code. What is mean by other pieces of code? For example, you are using a printf function. So you are not actually defining how printf should work in your C program. You are just using it, but you are using that to print your message, whatever the message you want to use. Okay, that actual program also brought into your program. So that linker will take care of it. So finally it will bring into a single executable file. Okay, so you will understand it more detail later on, but now it just assume it combines all other files to a single executable file. Okay, whatever the program you are written, with that it is also combining the existing source codes that are available and that you are linking to the program you have written. That is the job of linker. So this is basically linker is specific to compiled languages such as C and C++, so on so. Now what is the next? Loader. So loader is basically a program, again system program. It is not user defined program. When I say system program, it is basically used to manage the resources. When I say resources, what are the resources? Basically memory, CPU, so on so. Okay, and this system program loads the executable file. What is the executable file? Executable file is generated in the previous step, that is by either basically it's a linker. So linker generates executable file, and for linker we are giving, you can say first is what? First step is editing. Editor is doing, we are editing it. Then after that compiler, okay, or else interpreter. Then after compiler or interpreter we have linker. Okay, after linker then we have loader. So this is how loading is being performed to the main memory. So what is job of loader? As I said, it loads the executable file into the main memory for execution.